Welcome back, everyone. We're going to continue our lecture series on useful methods on Pandas series and data frames, and in part 3, we're going to talk about just general description methods and sorting methods. A lot of these methods are actually self-explanatory, so we're going to go through quite a few in just a little bit of time. So let's head back to that Jupyter Notebook and explore these methods further. Alright, here I am in the same Jupyter Notebook that we left off in last time. What I'll go ahead and do is just kind of reset everything by saying df is equal to pd read CSV. And I'm going to read in that tips.csv file again, just so we can have a fresh slate here. And let's start talking about just various method calls. A lot of these are pretty simple, and some of these you've even seen before, such as df.dscribe, which just shows you the general description of statistical methods. And as we previously discussed, sometimes these methods don't make sense for every column. For example, it doesn't really make sense to take the standard deviation for the credit card number column because the credit cards don't really have a mean. There should be some kind of unique identifier, versus it does make sense to take the average total bills or standard deviation of total bills and so on. So we've seen describe before. I also mentioned that I personally like to transpose this sometimes to make it more readable depending on what I'm actually looking for. Now the question comes up, how do I actually sort my data frame? Well, what you can do here is simply say df sort values, and then you provide the column that you want to sort by. So if I wanted to sort by the tip column, I say sort values, and now it sorts the tip column starting at the lowest all the way to the highest. And if you want to sort the other way around, essentially have ascending equal to false, then you simply clarify that. So by default, it goes in ascending order from lowest to highest, but you can also say ascending false to go in descending order from highest to lowest. Something to note is that it doesn't actually reorder your data frame in any way. It just sorts it by whatever particular column you're looking at. You should also note that you can actually sort by various columns or more than one column. So what I mean by that is, for example, we can see here that if I just sort by the tip column, so the first couple of tips are all the same. It's $1, $1, $1, $1. So that means I can sort first by the tip column and then sort by another column. Let's go ahead and sort then by the size of the party. And we notice we pass these columns in as a list. So what this does is it sorts first by the tip, and if there happens to be duplicate tip values, then it will sort by the next column over, in this case size. So if I run this, notice right now it's 1, 2, 2, 1 for the size. And now what it's gone ahead and done is it sorts by the tip, and then for each of those same tip values, it sorts by the next column, which in this case would be size, since I wanted to sort by size. So it goes 1, 1, 2, 2, and so on. So this allows you to sort not just by one column, but multiple column values. Next, I want to show you how to grab the index locations of the min and max values. So I can simply say total bill, and I get this series of total bill values. If I want the max total bill value, then I call max. If I want the index location of the max value, then I call IDX max. So I say IDX max, and this actually returns the index location of where this max value is happening, which means I could then say df.iloc, pass in 170, and I get back that particular series for that max value. And it's the same thing for minimums. I say grab the minimum or IDX min to get back that location, and then I could always pass that into 67. So as you can imagine, I could then grab this guy and pass that in here instead of actually providing 67 manually. So this will just grab the entire data frame row for wherever the total bill is the minimum, and it returns back the same results. So again, it's min and max, and then IDX max and IDX min. So grabbing the minimum maximum values, and then also grabbing the integer location. We can also do a quick correlation check. So there's the df.corr functionality, and this returns back a pairwise correlation of columns. So essentially it just tells you how correlated column values are with each other. And this in general only works with numeric columns, since you're doing something like a Pearson correlation coefficient. And you can check out the lecture notebook for a Wikipedia link on correlation and what it's actually doing. It's just saying how correlated these values are together. So do they go up together and down together, or when one goes up, does the other go down, or do they not have any correlation, so they're more around 0? So the max value is 1, so total bill is perfectly correlated with itself, and then the minimum value would be -1. Essentially, these two values move in exact opposite to each other. So when one's high, the other's low. And the range is -1 to 1, and always you'll see along the diagonal these 1s because each column is perfectly correlated with itself. And then you also notice that there's essentially duplicates across the diagonal because you're calling things twice. Tip versus size should have the same correlation as size versus tip. So again, you can grab those correlations with this core method call. So now that we know correlation checks, 𝑖𝒔𝒄𝒏𝒁 and 𝑖𝒔𝒄𝒏𝒂𝒏, I want to show you the value counts method. It's a very useful way to quickly get a count per category. And this only makes sense to call on a categorical column. So if I take a look at my data frame again, and I call df_head here, notice, for example, I have the sex column, which is categorical. It's either female or male. It's not a continuous value here, which means, let's imagine I wanted to figure out how many males I had and how many females I had. Essentially, how many counts do I have per possible value? The way we do this is you simply call the column you're interested in that's categorical, such as the sex column, and then say value counts, run this, and it's going to return back that you have 157 rows that are male and 87 rows that are female. And in a similar vein to the value counts method, there's also the unique method and the n-unique method. So maybe you have a column such as the day column, where we can say df_day, and if you run this, you're not actually sure what days are present in your data set. Well, what you can do is say unique, and it returns back the unique days that are present in your data set. In this case, it's Sunday, Saturday, Thursday, and Friday. What you can also do is then say n-unique, and that just reports back the number of unique values. So there was 4 unique days there. That's the same thing as just asking for the length of this unique array. And then if you, again, wanted to figure out, well, how many instances are there of each day, you could say value counts on this, and it shows you how many instances of Saturday, Sunday, and so on. So you have unique and unique, and then if you actually want to count these unique values, you can say, go ahead and give me the value counts. Now I want to talk about switching out or replacing values. I'm going to show you 2 methods. One is the replace method, and the other one is the map method. And they're kind of similar. One uses a dictionary, and one can use a list of values. So let's first show you the replace method. So if I take a look at df_head, let's imagine I wanted to replace female and male with just the letters F and M. So there's a couple of different ways I can do this. I'll first show you just how to replace a single value. Sometimes there's a value that's just incorrect or you want to switch out in your data frame. So that's actually really easy to do. You just grab whatever column you're interested in, say replace, and then the 2 parameters, it says what do you want to replace and what's the value you want to replace it with. So for example, I can say where we have female, go ahead and replace it with just the letter F. So you run that and you'll instantly notice we have Fs instead of females. This can also take in a list of values. We can say, okay, wherever is female, and then male, and then you just make sure that the next list is in the same order. So then you'll say, okay, F is for female, and then go ahead and say M is for male. You run that, and then that will go ahead and replace multiple values. That's the replace method. I highly recommend the replace method if you just are going to replace a single value. So for instance, maybe you had just some random null values. You can easily replace null values with like a 0 or something like that using the replace method call. Next, I want to show you the map functionality. The first step to use map is you actually create a mapping as a dictionary. So instead of passing in these lists here, you would actually say, all right, female should be mapped to F, comma, and male should be mapped to M. So you create this mapping dictionary, and then you call sex here, and you go ahead and pass in your mapping dictionary. So this will then go ahead and map these values to their matching values in this column, and you get back the same result. So I recommend the dictionary approach if you're going to do this for a lot of items. I think it's easier to read this way. And then replace, I recommend that if you just intend on replacing 1 or just 2 particular values and you want to keep the rest the same. So obviously you can kind of interchange these, but replace is easier with fewer items you intend to replace. mapping I think is easier if you intend to replace lots of items. And we just have a few more methods to show you here. Sometimes people ask me how you can deal with duplicated rows. So in this case, if you have duplicated rows, you can say df duplicated. And what this does is you'll notice each of these are unique. So there's actually are no duplicated rows in this. But if you had a duplicated row, it's going to return true for the very first instance of a duplicated row. So let me show you by creating a very simple data frame that actually has duplicates. I'll say pd.dataframe here. Let's say 1, 2, 2. And then we'll say the columns are or actually the index names, excuse me, are A, B, C. So here's my simple data frame. I have 1, 2, 2. If I ask for the duplicates on this, so I say go ahead and tell me where it's duplicated, notice it's going to return true on the very first duplication. So that means if I have another set of 2's here, let's go ahead and have this be D, and I run this again. So now I have the first unique, then the first duplication, the second duplication. I run this. It's going to start returning true on and after the first duplication. So just keep that in mind. It's going to mark the subsequent ones as duplicates versus the first ones, which is typically the behavior you want. And if you wanted to drop the duplicates, all you need to do is say drop duplicates. I'm just using tab to autocomplete this. And then it's going to drop subsequent duplicates. And just a few more method calls left, and then we finish off this section. Last one I want to show you that's sometimes useful is the between method call that actually will tell you which values in a particular column are between two values you choose. So I have a total bill column, and let's imagine I wanted to know the values for the total bill that happen to be between $10 and $20. Well, I simply call between, and then what I'm going to do here is pass in my lower limit, let's say $10, and my $20 limit. And then if I want it to be inclusive of these endpoints, so if a bill happens to be exactly $10, I do want that included. We can say inclusive is equal to true. We run that, and then it will tell me true or false, is this value of the total bill between $10 and $20, inclusive of the endpoints. So now that we have that, what I could do if I wanted is just use this as a filter itself. So if I say df and then pass this in as a Boolean filter, essentially using conditional filtering that we previously learned about, now it gets me only the total bills that happen to be between $10 and $20. Very useful tool here. Okay, so that's the between method. And then finally, I'm going to show you how to grab n largest and n smallest. So what I mean by that is we say df n largest. So this grabs the first n number of rows ordered by columns in descending order. So what does that actually mean? Well, let's say I wanted the 10 columns, or excuse me, 10 rows that had the largest tip. I run that, and now I get back, here are my 10 rows that had the largest tip. If I wanted just the first 2 largest tips, we run that. This is essentially just doing a sort value and then calling head. So you can imagine this is the exact same thing as saying df sort values by tip, and then just saying go ahead and just bring me back, let's say 0 to 2. And in this case, we'd want ascending to be false. So this is just a faster way of doing this. And as you can imagine, there's also n smallest, which gives me back the 2 smallest tips, which in this case would be the same thing as if I said here, ascending is true. And here are the same pieces of information. So there's n smallest, n largest. Just give me back the n number of smallest or largest values for any particular column. And last one I want to show you is sampling. Sometimes you just want to take a random sample of a data frame. You can call df sample. And what this does, if we take a look out here, there's 2 ways of doing this, which is really useful. You can either sample back a certain number of rows or sample back a fraction of your data frame. So what this means is if I just want to sample 5 random rows of my data frame, I say sample 5, and this will return 5 random rows. So each time you run this, you'll notice you should get back 5 different rows each time, unless you get super lucky. So this is, again, sampling 5 random rows. Or the other thing I could do is say df sample and say go ahead and sample based off a fraction between 0 and 1. So this will sample just 10% of the rows in my data frame. This is really nice because then I don't actually need to know how long or my rows in the data frame are. I'm just going to say go ahead and return back a sample of 10%. So grab 10% of rows in that table randomly. Okay, and that's it for all the useful methods. Again, definitely use the notebook as a quick and useful reference for yourself. Thanks, and I'll see you at the next lecture.